The Apollo 11 mission, conducted by NASA, marked a historic milestone in human exploration as it achieved the first manned moon landing on July 20, 1969. This monumental event not only demonstrated the technological prowess of the United States but also symbolized the collective efforts of humanity to reach beyond the boundaries of Earth. Mission overview. The Apollo 11 mission was the fifth crewed mission of the Apollo program and aimed to fulfill the ambitious goal set by President John F. Kennedy in 1961 to land humans on the moon and safely return them to Earth before the end of the decade. The spacecraft consisted of three main components: the command module, named Columbia, the service module, and the lunar module, named Eagle. Crew. The Apollo 11 crew consisted of three astronauts. Neil Armstrong, commander, the first person to set foot on the lunar surface. Buzz Aldrin, lunar module pilot, the second person to walk on the moon. Michael Collins, command module pilot, orbited the moon in the command module while Armstrong and Aldrin descended to the lunar surface. The journey. The spacecraft was launched from Kennedy Space Center on July 16, 1969, atop a Saturn V rocket. After a journey of approximately 240,000 miles, the spacecraft entered lunar orbit on July 19. The next day, the lunar module detached from the command module, carrying Armstrong and Aldrin to the surface. The descent. As Armstrong and Aldrin descended in the lunar module, they encountered a series of alarms and had to manually override the planned landing site to avoid a rocky area. With only seconds of fuel remaining, Armstrong skillfully piloted the lunar module to a safe landing in the Sea of Tranquility. One small step. On July 20, 1969, at 2:56 Coordinated Universal Time, Neil Armstrong descended from the lunar module and uttered the famous words, "That's one small step for a man, one giant leap for mankind," as he became the first human to set foot on the moon. Buzz Aldrin joined him shortly after, and together they conducted experiments, collected samples, and planted the American flag. Return to Earth. After spending approximately 21 hours on the lunar surface, the lunar module ascended to rejoin the command module. The spacecraft then began its journey back to Earth, splashing down in the Pacific Ocean on July 24, 1969. Legacy. The success of Apollo 11 was a testament to human ingenuity, courage, and determination. It not only fulfilled President Kennedy's vision but also left an indelible mark on the history of space exploration. The achievement of the first manned moon landing paved the way for subsequent Apollo missions and laid the foundation for the exploration of space beyond Earth's orbit. In conclusion, Apollo 11 stands as a monumental achievement that transcended national boundaries and united humanity in the pursuit of knowledge and exploration. The iconic images of Neil Armstrong's first steps on the lunar surface continue to inspire generations and serve as a reminder of the boundless possibilities when humanity sets its sights on the stars. Exploring the moon landing conspiracy theories. The Apollo 11 mission, which successfully landed humans on the moon in 1969, is considered one of the greatest achievements in human history. However, despite overwhelming evidence supporting the moon landing, a persistent set of conspiracy theories has emerged over the years, suggesting that the moon landings were an elaborate hoax. While these claims have gained traction in some circles, a closer examination reveals that they lack scientific merit and are largely debunked by experts in various fields. 1. Photographic anomalies. Conspiracy theorists often point to alleged anomalies in the Apollo mission photographs as evidence of a hoax. Some claim that the absence of stars in the lunar sky or the appearance of shadows in different directions indicates that the moon landing was staged. However, these anomalies can be explained by the unique lighting conditions on the moon, where the sun is the only source of illumination. 2. Flag-waving controversy. Skeptics often question the movement of the American flag planted on the lunar surface, suggesting that it shouldn't flutter in the airless environment of the moon. The flag's movement, however, is attributed to the momentum imparted to it during installation and can be easily explained by basic physics in a vacuum. 3. Radiation dangers. Conspiracy theorists argue that the intense radiation in the Van Allen belts surrounding Earth would have posed a lethal threat to the Apollo astronauts. However, NASA carefully planned the trajectories of the Apollo missions to minimize exposure to radiation, and the spacecraft's construction included shielding to protect the astronauts from harmful doses. 4. No stars in photographs. One common claim is that there are no stars visible in the photographs taken on the lunar surface. This is explained by the exposure settings necessary to capture the bright lunar landscape and the limitations of the cameras used, which were not designed for low light conditions. 5. Lack of impact crater. Some skeptics argue that the lunar module should have created a visible impact crater upon landing. However, the Moon's surface is covered in a layer of fine dust, and the descent engine of the lunar module was specifically designed to limit the creation of a large crater. Instead, it produced a plume of dust that settled back to the surface. In conclusion, the idea that the Apollo moon landings were a hoax lacks scientific validity and is contradicted by a vast body of evidence. The consensus among experts in relevant fields, including astronomy, physics, and photography, overwhelmingly supports the authenticity of the moon landings. While conspiracy theories may persist, a critical examination of the available evidence reaffirms the extraordinary achievement of the Apollo 11 mission and subsequent lunar landings. Exploring the future. Human lunar exploration initiatives. In recent years, the prospect of returning humans to the moon has regained prominence as space agencies and private enterprises embark on ambitious projects aimed at lunar exploration. With a focus on advancing scientific knowledge, testing new technologies, and preparing for future deep space missions, these initiatives represent a new chapter in human space exploration. 1. NASA's Artemis program. The United States, through NASA's Artemis program, has set a goal to return humans to the moon by the mid-2020s. Named after the twin sister of Apollo in Greek mythology, the Artemis program aims to land the first woman and the next man on the lunar surface. This mission will utilize the Space Launch System, SLS, and the Orion spacecraft, fostering international collaboration with partners like the European Space Agency, ESA. 2. Lunar Gateway. As part of the Artemis program, NASA and its partners are working on the Lunar Gateway, a space station that will orbit the moon. Serving as a staging point for lunar missions, the Gateway will enable sustainable exploration and facilitate the development of new technologies required for deep space exploration, including Mars missions. 3. International collaboration. Human lunar exploration is not limited to national efforts. The Artemis Accords, a set of principles for responsible space exploration, have been established, promoting cooperation between nations in lunar endeavors. This collaborative approach involves sharing scientific data, promoting peaceful exploration, and ensuring the sustainability of lunar activities. 4. Commercial space ventures. In addition to governmental initiatives, private companies are actively participating in lunar exploration. SpaceX, led by Elon Musk, has announced plans for its Starship spacecraft to transport humans to the moon and beyond. Other companies, such as Blue Origin, are also developing lunar landers and infrastructure to support human missions. 5. Scientific objectives. Beyond planting flags and footprints, the new era of lunar exploration emphasizes scientific goals. Researchers aim to study the moon's geology, understand its history, and investigate resources that could support future lunar bases. Water ice, for instance, is a valuable resource that could provide drinking water and be converted into hydrogen and oxygen for rocket fuel. 6. Lunar sustainability. Unlike the short-duration Apollo missions, current plans for lunar exploration emphasize sustainability. Establishing a long-term presence on the moon involves developing infrastructure, utilizing in situ resources, and leveraging advancements in robotics and artificial intelligence to enhance mission efficiency. In conclusion, the resurgence of interest in human lunar exploration reflects a broader commitment to expanding our presence in space. With a combination of government-led initiatives, international collaboration, and private sector innovation, humanity is poised to return to the moon and pave the way for future deep space exploration. The lessons learned from these endeavors will not only benefit scientific knowledge but also lay the foundation for the next chapter of human exploration beyond Earth's orbit.